Okay, so we've got two particles, and this time they're hanging. So B is hanging below A, and a force of 180 newtons is applied vertically upwards. Okay, so as always, and this one is has the E there, which means they're saying it's very much an exam level question, an exam style question. Okay, so did I want to close that? Sorry. Right, so I wanted to go on to that. Okay, so we're going to draw a sketch of that. So we've got A is the top one, and then B is hanging below it. And a force of 180 newtons is applied vertically upwards. It doesn't really say where that 180 newtons is applied. So whether it's sort of pushing B up, or I guess if it's a string, it must be pulling A up. And I know that the mass, so there's going to be tension in that string. The mass of B is 5 kilograms, so the weight of B is 5g, and then it's getting a little bit messy, but the weight of A is 10g. Okay, that is working downwards rather than off at an angle. Okay, so they want to know the magnitude of the acceleration. Okay, so the magnitude, just the size of it, clearly it's going to be upwards, I guess. Well, actually, I suppose that depends. Yeah, it depends on how the 180 newtons compares to the total force. It might not be working upwards. Okay, so okay, I'm going to assume that it is. And if I've got that the wrong way around, that's fine. I'll just get a negative result. So part A. So as long as I know which direction I'm taking as positive, it'll work out. So the total force. So using F equals ma, I'm modelling sort of the entire body together. So the upward force is 180 newtons. Then we've got the 10g and the 10g and the 5g downwards. So I can combine those to say there's a resultant force of 15g down. And that equals the total mass, which is 15 kilograms, times the acceleration, which I'm trying to find. So 180 minus 15 times 9.8 is 33, and that equals 15a. So a is going to be 33 divided by 15, so 2.2 meters a second squared. Okay, and then part B wants me to find the tension in the string, so I can look at particle A or particle B for this. It doesn't matter which one. If I was really wanting to double check my answers, I could do both. So let's just look at particle B. So particle B has got tension in the string pulling it up, its own weight pulling it down, and we've worked out, so we were taking up as positive. It's really important I'm clear about which direction is which. So I was taking up as positive, so acceleration upwards is 2 meters a second squared. So if I'm taking up as positive, then t is working up, and then minus the 5g that's working downwards, and that's its mass at 5 kilograms multiplied by the acceleration. So t is going to be 5 times 2.2 plus 5 times 9.8. So t is going to equal 60 newtons. Lovely.